Lab 1 charged tape. This is the introduction and preview of the results. You can see the calculated magnitude of the charge as well as the computational model of the charge. And we also found that the U-tape was negatively charged, and we determined this by rubbing a pen on wool, creating a negative charge, and seeing how the pen interacted with the U-tape, and they repelled each other, so we knew that the tape was negatively charged. And two U-tapes made in the same fashion repelled each other as well. The purpose of the lab was to experimentally determine the temporary charge of a tape when it's ripped from another piece of tape, where under normal conditions the tape would be neutrally charged, and this also demonstrated Coulomb's law and Newton's second law. So here are the physics principles demonstrated in the lab. So first we have Coulomb's law, which describes the charges and interactions between different objects. So we had a bottom tape and a top tape, and the top tape floated over the bottom tape because of the repulsion between them. And also Newton's second law was demonstrated because the top tape had the force of gravity acting on it as well. And in this lab, to determine the charge of the tapes, we set equal the force of gravity to the force, the electric charge force, to determine the charges of the tapes. So the system was the tape on top, and the surroundings was the tape on the bottom and earth. And the procedures followed to create the tapes was folding one small end of the tape and sticking it to the table, repeating the same thing with another piece of tape and sticking that tape on top of the first tape, and then ripping to create the charge. The initial conditions, assumptions, and approximations were that the tapes initially had a neutral charge and that the forces acting on the tape were equal and opposite in magnitude. So that would be the gravitational force and then the electric force from the bottom tape. And this could be assumed because the tape was floating and not moving, so the acceleration was 0. And then we assumed that the tapes were single point charges. And then here are all of the values used for calculations, and then the gravitational force calculated by hand was 7.84 times 10 to the negative 5 newtons, and the magnitude of the electric force calculated by hand was 7.84 to the negative 5 newtons, since they were equal, and then the electric charge is 7.467 times 10 to the negative 9 coulombs. So here's the coding and computational model. You can see in the first 10 lines we put in all of the values and measurements, and then lines 13 through 16 were for calculating the gravitational force, and then we also calculated the electric force through the code. And then you can see on the right the results. So the green dot would be the top tape and the blue dot the bottom tape, and there's gravitational force acting on the green top tape as well as electric force from the bottom tape. And then we can also see the values from the computational model below. So the model versus experimental findings were very similar. As we can see, the numbers were very close. So overall, the model and experiment were pretty similar. So for the what if electrons had positive charge and protons had negative charge? So this wouldn't really affect the results of the lab because charges repel and different charges attract. So the tapes would still repel each other since they were created in the same way and should still have the same charge, whether it be positive or negative. The only thing that would change would be how the tapes interacted with other objects. So since the tapes were negative, they repelled other negatively charged objects. If they were positive, for example, then they would now attract. For the why is it important to handle the charged tapes as little as possible? This is important because handling the tapes can lead to charge interactions and transfers of charge from the movement of electrons. So the negatively charged tapes may become more neutral as electrons are transferred when you touch them or have them in contact with other objects. So potential sources of error were calculation errors, assuming the negligence of air resistance, and then one thing was that the negatively charged U-tape also attracted to neutral objects, which in theory it shouldn't, but there's several possible explanations here as listed, like it being winter and more static electricity, etc. And that's all. Thank you.